My name's Simon Patton. I'm the Managing Director of EMQN, and it's a warm welcome from myself and all the faculty and AstraZeneca, GenQA and EMQN to our webinar on round 6 of the BRCA variant classification competence assessment EQA activity. I'm just going to do a few basic introduction slides, and then I'm going to hand over to my colleague, Professor Sandi Deans, who's going to give the introduction to the webinar. So next slide, please. So just a few housekeeping issues for you. So your microphones will have automatically been muted. Please only unmute your microphone when you need to, if you want to say anything, but in most cases, the opportunity for doing that will be potentially at the end. I'll explain a little bit more about the Q&A though in a minute. Please note that the webinar is being recorded, and it's our intention to make this available to you and your colleagues for later use, both for training and for revision of the activities that we've talked about. We'll let you know, I think we're anticipating once it's been through compliance, it takes about 2 weeks for us to make it available to you, but we will let you know by email, by GenQA and EMQN when that's available to you. And most importantly, this is an interactive session, so it is, we're here to try and provide education, help you learn, associated with it, with this webinar. So your interaction with us is important. So we have made available to you a Q&A session. So at the bottom of your Zoom window, you should see an indicator saying Q&A. You can use that section to log your questions to us at any time you want during the webinar. We have about 10 minutes allocated at the end, depending on how long it takes to go through the variants, where we're going to, the expert speakers will be answering some of your questions. But please be assured that even if we don't get around to answering all of your questions now, and we typically don't get to, then we will be summarising our responses to you in our report after the BRCA variant assessment is closed. Next slide, please. So finally, your feedback is important to us. It helps us improve, and it helps us to provide better quality training to you as healthcare professionals. So you should, after this webinar has taken place, receive an email with a link to a short feedback survey. We would be very grateful if you could spare a couple of minutes just to answer that feedback survey and give us your thoughts, see what we can do to improve, how we can help you in future. Okay, next slide, please. So I'm going to hand over to my colleague, Professor Sandi Deans, who's going to give you the introduction now. Over to you, Sandi.
Thank you, Simon. So I'd just like to add my welcome to you all, and it gives me great pleasure in introducing our expert panel today. So the webinar is ensuring the correct classification of BRCA1 and BRCA2 variants. This is the first of a series of educational webinars, and we are planning to host a second set of webinars in the autumn that will cover other HRR gene variants. So we are very pleased to welcome Dr. Emma Howard to our expert panel. Emma is the Operational Director in the West Genomic Laboratory, based in Manchester and Liverpool in the UK, and also Miranda Durkie, who is the Lead Clinical Scientist in the East and Yorkshire Genomic Laboratory Hub, based in Sheffield, Leeds and Newcastle, GLH, in the UK as well. So next slide, please. These are just the disclaimers and disclosures for you to review. So next slide, please. So the aims, as I say, for this series in the spring, we're going to provide 2 educational webinars, and the focus is to promote accurate classification of BRCA1 and BRCA2 gene variants. This is going to follow the following format. We've got our masterclass expert panel webinar today, whereby we're going to have a presentation around the best practice guidelines that are currently available for us to use, and in particular those that are related to BRCA1, BRCA2 gene variant classification. We're also going to present a summary of the resources that are available to us and work through some worked examples. So we have 6 variants, a mixture of BRCA1, BRCA2, varying different challenging variants to look at. We then will open from this afternoon online access to the GenQA Genomics Training and Competency Assessment Tool, so GTACT. This is an online participation. You can access it wherever you are. If you don't have already registered to access it, then please contact us and we can set that up for you. It's online, so participation is open to everyone, and it's individual participation, so it's not laboratory based, so it can be used for your own CPD and CME going forward. So the ask is to classify 6 different BRCA gene variants and summarise the criteria that you have used for that classification. So it's all online, drop-down menus, very easy to use, and then you can submit. What you can also do is download your own responses and your submissions. So when we meet again on the 30th of June for the second webinar, you can follow your own classifications and evidence used as the expert panel goes through their processes and the evidence they use to classify the same 6 variants. And we'll also at that time be able to give you a summary of the EQA outcomes. So please note that this second webinar timing has changed. It has been delayed by a couple of weeks. So we're now going to hold that second one on the 30th of June, but you will be notified and your Outlook calendar invites will be updated following this webinar. We'll also very importantly have a question and answer session just like today to address some of the issues for those variants in the EQA run. So next slide please. So the objectives really from these combination of webinars is to provide an overview of the framework to classify variants according to the current best practice guidelines that we have to work with. Also to outline the mechanism of classifying somatic variants according to these best practice guidelines. And as I said, to summarise the resources that are available that are specific to BRCA1 and BRCA2 genes. We're also going to work through some examples of BRCA variants. And as I said, we will have a mixture of simple variant classification and complex classifications. And we've got 6 examples to provide for you today. So next slide, please. So I'm now going to hand over to Dr. Emma Howard, who is going to start off with a summary of the current best practice guidelines that are available. Emma, over to you now, please. Thanks.
Thank you, Sandy, for that introduction and welcome everybody today. So as Sandy said, myself and Miranda will just talk through a general introduction where we'll introduce BRCA and then the guidance associated with the interpretation of the variants within those genes. Can I have the next slide, please? So a very broad overview initially. You all will know and very aware that BRCA1 and 2 are large tumour suppressor genes with a range of mutations that run throughout the genes, which include also exon deletions and duplications. And really nice schematics demonstrate not only the spread of mutations throughout these 2 genes, but also the protein domains, functional domains are also illustrated here too. Next slide, please. And just to run through some of the different variant mutation types in BRCA1 and 2, let's start first of all with missense. We see these in the genes, but in specific functional domains too, primarily where the more pathogenic missense mutations are focused. And this is basically a substitution at the nucleotide level, which introduces a new amino acid. Frameshift mutations are also demonstrated throughout the genes, and this either an introduction or reduction of a nucleotide base, which results in a stop codon being introduced in the downstream. Nonsense mutations are also seen, and this introduces a stop codon by a substitution of a base. And then we've also got large rearrangements that are seen in the form of duplications and deletions throughout the genes too. Next slide, please. So this slide just demonstrates the classification system, and it's based on the original IARC5 classification system. It's really important when you do variant interpretation that you're able to establish a causal role of mutation and whether it's deleterious. And this is ranked from class 5 to class 1. Class 5 being that pathogenic, and this result confirms the diagnosis. Class 4 is likely pathogenic, which is consistent with the diagnosis. And for these 2 classes, you would then go on to test at-risk relatives for the variant and perform full high-risk surveillance for the patient. Class 3 is denoted as uncertain pathogenicity. And here you would not confirm or exclude a diagnosis. Class 2 and Class 1 Class 2 is unlikely to be pathogenic, so likely benign, and class 1 is considered not pathogenic, so benign. And for class 3, you wouldn't expect to do predictive testing in at-risk relatives, but you may increase surveillance for the patient. But with class 1 and 2, you would not do any extra surveillance for the patient or the relatives of that patient. Although this is a classification system, what comes before the classification system is a whole raft of interpretation of the variant to get to that point. Next slide, please. So basically, this slide just demonstrates the variants that we consider to be class 5 pathogenic. Next one, please, if we could just press. Thank you. So first, initially, truncating mutations, but there are some exceptions to this, particularly in BRCA1 nonsense or frameshift mutations in the last 10 amino acid of the gene. And also, likewise, for BRCA2 in the last 110 amino acids. And this is because they're in the last exon, which does not undergo nonsense-mediated decay. Next one, please. Turning to splicing mutations, mostly +1, -1, +2, -2, and the congenital splice sites can mostly be assumed to be pathogenic. However, you shouldn't assume a splicing mutation is, and obviously +3, -3, or up to +6, -6. They may affect splicing, but they're far less predictable, and a full interpretation should be considered. And some exceptions are there for even the +1, -1, +1, +2, and these are demonstrated in the Enigma paper and should be consulted. And so you shouldn't basically assume anything, and interpretation of the variant should also always be carried out. Next one. Thank you. So in terms of missense variants, these are usually can be pathogenic when they affect highly conserved residues in a functional domain. For example, in the BRCA1 ring finger domain, or the BRCA domain, or the BRCA2 DNA binding domain. But we shouldn't assume anything with a missense variant, and a full interpretation should be carried out. Next one, please. And lastly, large rearrangements and deletions. And most large deletions are pathogenic, but you should apply some caution when you're considering in-frame deletions. There is a BRCA1 exon 13 duplication, which is a very common founder pathogenic mutation in the UK. And other large duplications not described in the literature should actually be proved to be in tandem before they can be considered as pathogenic. Okay, next slide, please. Just wanted to run over some of the terms that we see for class 3 unclassified variants. And this is defined as a variation in a genetic sequence whose association with disease risk is uncertain. And we see different terminology around class 3, in the unclassified variants being one, variant of uncertain significance, a variant of unknown significance. It's sometimes abbreviated as UV or a VUS. So just to be aware, these all refer to a class 3 variant. Next slide, please. And just an introduction in some of basically a historic guide to some of the guidelines that have been in place over time. It started basically with the CMGS guidelines, and I think, and quote me on this, I think it was 2008 these were initially released, and they were updated and with a more focus on rare disease, I should say, with the ACMG release in 2015. The ACGS then took the ACMG and basically adapted them slightly, and there was many iterations of this in 2017, then followed 2018, and finally we've got the latest draft, which is on the ACGS website, of the 2020 iteration of these guidance. Next slide, please. This is my final slide before I hand over to Miranda, but also just to raise that there is another set of American molecular pathology guidance, which is focused more on the somatic setting. And although I wouldn't recommend using these solely for BRCA, but BRCA is seen in the somatic setting. Sometimes we use them in association with the ACGS guidance as well. And basically this is an evidence-based categorization for somatic variants, and they're classified into 4 different categories dependent on their level of clinical significance in cancer. and they looked at for diagnosis, prognosis, and therapeutics. So variants in tier 1 have the strongest clinical significance, and variants in tier 4 are considered benign or likely benign. And they take into account things like an FDA-approved therapy, or well-powered studies from clinical trials in order to denote which tier the variant sits within. So it's just to raise awareness that they are available for you and are particularly applicable for other cancers in the somatic setting at genomic tumour advisory boards. So I'm going to pass to my colleague Miranda, who will take you through the next set of guidance slides. Thank you.
Hello everybody, thank you very much Emma for that great introduction. So I'm going to continue with the variant interpretation, and next up kind of on the list is the Enigma rules for classification. So I'm sure you're all very familiar with Enigma. They're a very important and well-established group, an international consortium that's been focused on variant interpretation within BRCA1 and BRCA2, and they've actually developed a multifactorial model. So this mathematical model puts in pieces of data from things like family history, pathology, co-occurrence in trans, in silico tools, etc., to come up with a likelihood ratio and therefore a probability of pathogenicity for variants. And this model has been used to classify a large number of variants, so most recently seen in the Parsons et al. 2020 paper. So I've just highlighted here that those guidelines are specific for the more high penetrance variants rather than those with the lower or intermediate or moderate level of risk. The other thing I want to say about Enigma is that they are the designated expert group by ClinGen for developing BRCA1 and BRCA2 variant classification guidelines. So they are working to adjust their framework to kind of fit with the ACMG criteria. So this is still work in progress, and we're not expecting any kind of guidelines in the imminent future, but hopefully soon. Next slide, please. So on our historical journey through variant classification, the next up, obviously the very key seminal paper by Richards et al. 2015, and this is some joint guidelines from the ACMG and the AMP. And they came up with these 28 different criteria or codes covering a variety of different evidence. So this includes things like population studies, functional analysis, segregation data, is the variant seen de novo, in cis, in trans, and also some of the computational predictions. So once you have your piece of evidence, you can try and fit it to one of the codes. So the only caveat is that sometimes it fits into more than one code. So you have to be quite cautious about not double counting the same piece of evidence twice. And then the table at the bottom shows, as well as having the different criteria and the different categories, is you've also got different strengths you can apply. So for the pathogenic categories, you can apply these at the strengths going from supporting, moderate, strong to very strong. And it's slightly different for the benign criteria. They can go supporting, strong, or standalone. Next slide, please. So this slide lays out all 28 of the different codes. So you've got the along the top, on the left, the benign criteria, on the right, the pathogenic criteria. And then they're also divided up into the different strengths that can be used, and along the left-hand side, the different criteria of evidence that can be used. So when you're gathering all your data for variant interpretation, you'll gather all your evidence and you'll fit the different pieces of data to these different codes. Next slide, please. And then you'll kind of add those codes together, and then your accumulated criteria you would then compare to the classification table. So the one on the right is from the ACGS 2020 guidelines, which has been slightly updated since the original Richards et al. Paper. There's also an equivalent one for the benign in Richards et al. And if you have insufficient evidence to reach a conclusion, or you've got conflicting evidence of pathogenicity, it may well be that your variant fits into the uncertain significance. So what are the issues for cancer susceptibility? Well, these guidelines were very much developed for rare disease with rare phenotypes. So there are quite a few categories that aren't really very applicable to us, for things like we very rarely see de novo variants. And when we're doing segregation analysis, because it's a late onset disorder showing reduced penetrance and also unfortunately has a high mortality, we very rarely get these large families available for segregation analysis. Next slide, please. So to try and address some of these issues, in 2017, the Cancer Variant Interpretation Group at UK, so CANVIG UK, was set up, and the aim was to develop some cancer susceptibility gene specific guidance, and this was published kind of last year, and it's they're also being updated regularly, so we actually have some draft 2021 guidelines that are currently circulating for approval. On the right hand side, just wanted to draw your attention to another CANVIG paper that actually shows how you can combine the evidence for and against pathogenicity, and also what criteria you can and can't use together to avoid that double counting. Next slide, please. So I wanted to highlight this as a fantastic example of how the CANVIG guidance and the group has really helped the reclassification of lots of VUSs. So from Richards et al., PS4 is defined as the prevalence of the variant in affected individuals is significantly increased compared to the prevalence in controls. But in order to actually calculate that, you need big case control studies. And we're very lucky in the UK, there's been a big project to get all the genomics labs to submit all their data to Public Health England, who then match it up with the cancer registry, and then that aggregated data is then released back to CANVIG and is put on the CANVIG UK website. And we can then use that data to look up the number of UK cases with a variant or where it's wild type, and we can compare those to ethnically matched controls from NOMAD. And using this very simple fit as exact test, it will give us a p-value that means we can use PS4 all the way up to very strong. And this has enabled us to reclassify numerous variants that were stuck at VUS level using this case control evidence. Next slide, please. So there are lots of other areas that we've kind of made the guidelines a bit more cancer susceptibility gene specific. So they are shaded grey in the appendix of that publication. So just to highlight another one quickly, is PM1 in Richards et al. It says it's you could apply PM1 for a well-established functional domain without benign variation. So obviously in BRCA1 we've got the BRCT and the ring domains, and BRCA2 we've got the DNA binding domains. But all those domains still do show some benign variation. So therefore in this version of the guidelines, we've specified that you can use PM1 supporting for some key residues that have been listed by Enigma with it, and it's got the link at the bottom of the page. Next slide, please. And just finally, I wanted to show you some of the things that are coming up in the new 2021 guidelines. So as I mentioned, Enigma have this multifactorial model, and we've actually developed a method in order to convert the likelihood ratio or the log likelihood ratio from the Enigma multifactorial model into the evidence points and then into the evidence strengths, that we can use that evidence, it's still in the ACMG framework while we're waiting for those guidelines to come out from Enigma. Another amazing resource is we've put together an XLS of all the different functional studies that have been done, and the CANVIG steering group have assessed all of those according to the functional guidelines, so Brunich et al., and it gives a good summary of them, and also importantly tells you what strength you can apply PS3 and BS3. So the link to the CanGene CanVar website is there if you want to have a look at those ratified guidelines. Next slide, please. And now I'm going to hand back to my colleague Emma, and we're going to go through some variant classification examples from Run 4.
Thank you. Thanks for that, Miranda, for that excellent summary and bringing us right up to date to where we are with the new guidance as well. Thank you. So turning now our attention to the variant classification, we've got 6 variants to go through. The first are quite simple classifications, and then we'll move to the more complex ones. So can I have the next slide, please? So variant classification 1. For variant 1, here, next slide, please. Okay, so first of all, this is a BRCA2 variant. It's a synonymous variant. It's at nucleotide 750 with a G to A substitution, resulting in a violin amino acid 250 to violin, because it's a synonymous missense variant. Like I say, it was in BRCA2 and it's not in a functional domain. Next slide, please. So BRCA2, these are for this particular variant, these are the databases or the resources that we've interrogated. So we'll take them in turn in the table. We've got BRCA share. It is on BRCA share, but it is as a note as being unclassified variant, but a class 3, with a note saying it has been scored differently by different curators. It is on NOMAD at 0.0078%, which is low. We've also, it's seen on BRCA exchange and is denoted as likely benign. It's not on HGMD. It is on ClinVar and it has a 3-star rating and because it has been reviewed by an expert group, which was the Sharing Clinical Reports project. The REVEL score in this is not applicable, and other information such as splicing algorithms, which are within ALAMET, it has been reviewed and there was no predicted impact on splicing. Next slide, please. So this is also, because it's a synonymous variant, it's important to scrutinise the nucleotide conservation at that base. So this is base nucleotide 750. You can see here with the ringed area that it's a very low conservation at this nucleotide. Next slide, please. And so therefore, to summarise, there was no evidence favouring that this was a pathogenic variant. There was 2 pieces of evidence that suggested this was a benign variant. So we used BP4 supporting because the splicing prediction programmes showed no impact. And we also used BP7 supporting because, like I've just illustrated in the slide previously, this is a synonymous or a silent variant at a weakly conserved nucleotide. There was a paper by Jahel et al. In 2017, which indicated a splicing transactivation study with this variant, and it suggested it was likely benign, but there was no other data except some narrative. So we weren't able to apply a benign functional piece of evidence here. So we did not use BS3. So in overall, the summary for this is BP4 supporting, BP7 supporting, which gives you prediction of class 2 likely benign. Next slide, please. So this is the classification of variant 2. Next slide, please. This is also a BRCA2 variant, which is a nucleotide 1013. It's a deletion, and it also results in a frameshift variant. And it is not in a functional domain. Next slide, please. So again, the resources that we interrogated in order to interpret this variant were BRCA share, which it wasn't present. It was not present on NOMAD or BRCA exchange or HGMD or ClinVar. There was no effect on splicing with the prediction tools in ALAMET, and the REVEL score is not applicable in this situation. Next slide, please. So this is just to demonstrate that actually this is a loss of function variant. So the piece of evidence that we can use, and it's not on NOMAD. So that would give us a very strong piece of evidence, PVS1, and the moderate, because we would use PM2 because it's not on NOMAD. But as Miranda said in the introduction slides and was able to illustrate, that there's been an updated table from what was originally released in the ACMG guidelines in 2000, so in the Richard et al. Paper in 2015. And this gives you, if you use the old table, which is on the right-hand side of your slide, you'll see that a very strong, so one very strong and a one moderate piece of evidence actually makes it likely pathogenic. But turning to the table on your left-hand side, you'll see that this is the modified version, which is based on new Bayesian modelling from Sean Tatajivian in 2018, and actually a very strong piece of evidence, and a moderate in this circumstance, in this new table, would give you a pathogenic variant. So it's just important, and I wanted to demonstrate the use of the most up-to-date table. It is highly recommended because it actually gives you a more clarity on your classification around some of these changes that have been made. Can I have the next slide, please? And therefore, just to summarise what I've just said in the previous slide, we had a PVS1 very strong, which is because we've got a null variant in a gene where loss of function is a known mechanism of disease. And we had PM2 and the moderate because it was completely absent from controls on NOMAD. There was no benign variant, evidence for benign variant. And so overall, we had a PVS1 very strong, PM2 moderate, which prediction is class 5, which is pathogenic. Next slide, please. So my final classification is for variant 3. So next slide, please. And this is another BRCA2 variant, which is at nucleotide 3620, giving a substitution of an A to a G, and tire 1207 cis at the protein level. This is a missense, non-synonymous variant, and it is not in a functional domain. Next slide, please. Again, the resources that we looked at were BRCA, which it was not present. Nomad, it was present, but it was at 0.0004%. It was on BRCA Exchange, but it's not yet being reviewed. It's not on HDMD. It is on ClinVar as an unclassified variant. The Revel score, which is applicable because it's a missense variant, is 0.282. And the other missense prediction tools, which are embedded in Alamet, such as CIF, Polyphen, Align GVGD, and Mutation Taster, all predicted that this was a benign variant. And just to note, the Revel score, which has had I've raised its profile more recently as the more preferable option around missense prediction tools, because it looks at more tools basically to come up with a point score. And this can be assessed, and you can get this through Varsome, and I've put the link there. Okay, next slide, please. So there was no evidence favouring pathogenicity for this variant, and the evidence favouring a benign variant was a BP4, so a supporting piece of evidence at multiple lines of computational evidence support a non-deleterious effect. And this was also supported by the Revel score, because under 0.4 you can apply this benign piece of evidence here, and our Revel score was below that. And we also, other evidence, the only other piece of evidence was this paper where it suggested that in BRCA2 domain, this is a cold spot for missense pathogenic mutations, but it doesn't reach the BP1 criterion in the ACMG guidance. And what they said was that of the 34 pathogenic or likely pathogenic missense variants in BRCA2, none are in exons 10 and 11, and this variant does sit in 11, but it doesn't give us enough evidence to apply this piece of evidence here. So basically, we've only got one benign piece of supporting evidence. So the overall classification for this is a class 3 unclassified variant. And I'm going to hand over to Miranda now to continue with variants 4 to 6. Thank you.
Thank you very much, Emma. Just before we get started, just a reminder for participants that if you want to submit a question for us, just please put it in the Q&A. Thanks. And also, I was going to say that you can also get the Revel scores on the CanVar UK website if that helps too. Okay, so now I'll carry on. So variant 4, next slide, please. So this is a BRCA1 missense variant, C.1648A to C, and it is a missense variant that's not sitting within one of the key BRCA1 functional domains. Next slide, please. So a summary of all the databases and resources that we've looked at. So this variant's actually been fairly well reported. It is on BRCA as a neutral variant. It has been reviewed on BRCA Exchange and classified as benign. HDMD had some conflicting data, and it was on ClinVar as being benign, and the Revel score is low, below 0.14. What I wanted to highlight was this Nomad data. Next slide, please. So when you're looking to see if you can apply BS1 for your kind of case control data, the best population to select is to go on Nomad version 2.1.1 and select the non-cancer controls. And then for BRCA1 and BRCA2, you're best off comparing to the non-cancer females. So I've highlighted here in the box that when you kind of see a result like this, we've got an allele frequency of around about 0.01%, and about 19 alleles, you may kind of be umming and ahhing about whether you should apply BS1 or not. And there's been a fantastic tool developed by Nikki Whiffin and James Ware's group called the CardioDB Allele Frequency app. And on that app, you can plug in your disease prevalence, your disease penetrance, genetic heterogeneity, and allelic heterogeneity. And that gives you your maximum tolerated allele frequency that you can use for BS1. But the good news is that you don't need to do all of that because we've already done that for you. So if you look on the CanGene CanVar resources link that's on the slide, then the presentation's present there, and we've calculated BS1 and BA1 frequencies for BRCA1, BRCA2, PALB2, and all the Lynch genes. Next slide, please. So to summarise the data for this variant, there was no evidence for favouring it being a pathogenic variant. So then the evidence favour it being a benign variant. I've kind of given the game away, but actually when you go through and have a look at the presentation and apply that level of BS1, this variant does meet BS1. Interestingly, for this variant in run 4, more participants use PM2 than use BS1. So yeah, this hopefully will help you. In addition, there's a BP4 applied because it was identified in trans with a known BRCA1 pathogenic variant. And there are functional studies showing no effect on homologous recombination. And we've also got the Revel score showing so we can apply BP4 as well. So in summary, this is if you are applying the BS1 as well, you can get this variant to a class 1 benign variant. Next slide, please. So variant 5, next slide, please. So this is another missense variant, BRCA2 this time. So this is a C.7978T to G. And this time, this variant is present in the DNA binding domain. Next slide, please. And when you look at the different databases and resources, it was not present on BRCA share. It was not reviewed on BRCA exchange. HGMD was listed as a question mark, disease causing mutation. ClinVar listed it as a likely pathogenic variant. It has got a very high Revel score and it was not present in NOMAD. Next slide, please. So this one should be fairly straightforward, but actually only about half of the participants used PS3, and which was quite critical to being able to kind of classify this variant. And so we've got 3 different functional assays there that showed an abnormal function. Using the Brinich et al. Guidelines, the Godigli 2018 paper meets PS3 strong, and the Mesman paper meets PS3 moderate. So you can apply PS3 strong for those assays. And then even less participants use this PP1, which is the segregation analysis, but this was what was really key to kind of help boost up that pathogenicity score. So there are 2 key papers that actually showed segregation of over 10 myoses from 8 different families, and that was calculated using Jarvik and Browning, just calculating the segregation in the affected individuals. So in addition, we used PS4 moderate because the variant was observed in multiple unrelated affected individuals from publications and various databases. It was absent from NOMAD, so we applied PM2 moderate, and the Revel score allowed us to apply PP3 supporting. So in summary, we've classified this variant as class 5 pathogenic. Next slide, please. Variant 6, next slide, please. This one's a slightly more tricky one. So it was a BRCA2 del ints, and this causes a frame shift to the protein. And generally with a frame shift, you just assume the prior risk of pathogenicity to be very high. Next slide, please. However, when you start looking at the databases and resources, there's some conflicting information. So it's on BRCA share as benign. It's not been reviewed on BRCA exchange. It is reported on HGMD as a disease-causing mutation, and on ClinVar it's conflicting. Obviously, we can't use the Revel score for this type of variant, and then it was really the NOMAD data that kind of caused problems. So next slide, please. So if you're going through a tool such as Alamet and you're looking at the del-ints, it will show you that that variant isn't present on NOMAD, but I would always recommend going and looking at NOMAD yourself, because actually in this case it's listing two, right at the same position, two separate insertion events, and you can see they've been seen at a frequency of 69 and 73 alleles. And if you just scroll down the page on Nomad, you get this window showing the different BAM files, and you can load as many of these BAM files as you want, and you can kind of see the purple lines that shows you those insertions. So you can clearly see from the BAM file that those two separate insertion events, as they're listing them, are actually in cis. And then when you work out the HDVS, it is our variant of interest. Next slide, please. So a summary of the evidence. So the evidence favour it being a pathogenic variant. It was reported as pathogenic in pancreatic cancer by this publication. Unfortunately, if you go and read the publication, there's no evidence supporting that why they've called it pathogenic. I think they just saw a frame shift and didn't realise that the frame shift variants or truncating variants near the 3' end of the BRCA2 gene aren't necessarily pathogenic. So as I've demonstrated, that we can use BS1 because the allele frequency is actually greater than 0.02. Actually, in this case, about double the number of participants use PM2 compared to BS1. So it's yeah, it was a tricky one, but one to watch out for. And then we also used BP2, which is the co-occurrence with another class 5 variant in trans. And then the other evidence that is absolutely critical for this variant, that's actually really hard to apply using the ACMG criteria, is that we know that BRCA2 truncating variants downstream of the residue P3309 are not clinically important. So that's been demonstrated by the functional assays, and obviously we've got the common LICE 3326 variant. Next slide, please. I think that's, yeah, I'm going to hand back over to Sandi now.
Thanks, Miranda. And thank you also, Emma, for running through the variants. That's fantastic, and a lot of background information there, which is great to be able to help guide through variant classification. So next slide, please. Lovely. So this is just a summary of our next steps. So please, if you wish to participate in the next BRCA variant run, the website here is where you can register. Once you've registered, you'll get, is confirmed, you'll receive instructions how to log into the system. As I mentioned, it is going to start from this afternoon. We're good to go live. So that's actually available from the end of the webinar, and we'll run to the end of May. You can log in and complete your classification and submit the details of the criteria applied online, and then you can download the report of your own submissions. Then you will be invited to join the webinar on the 30th of June and join us with our expert panel again to review the variants on this EQA run, and then have a question and answer session whereby we can actually discuss some of the variants if you wish to raise some issues. So you just need to then log into your account, and you can download your assessed report and participation certificate after the 30th of June event. So next slide, please. A very big thank you for our expert panel. And now we're going to pass over back to Simon and run our question and answer session. So once again, we've got some questions in the Q&A box, but please do submit your questions and we'll try and work through them. If we can't get an answer today, we'll definitely include them into the EQA run summary report, so everything will be shared with everyone at a future date. So Simon, can I come back to you now, please? Thank
you very much indeed, Sandi. So welcome back. So it's over to me to try not to put my colleagues and fellow presenters on the hot spot, but really this is your session to get as much out of this webinar as possible. As we said before, please do use the question and answer facility for asking your questions. We've got a number coming in, so I'm going to start off with a couple of questions really for our speakers. So the first question is from Miranda. So ClinGen have recently published a recommendation that PM2, or absence or rarity in controls, be downgraded from moderate to supporting. How will that affect variant classifications in BRCA1 or BRCA2, and how will the change be implemented?
Thank you, Simon. Yeah, that's an excellent question. The first part is, how is it going to affect the variant classifications? Well, obviously there's a significant worry that particularly the rare missense variants that are sitting around that likely pathogenic and VUS border will end up being down classified without any real change in their evidence. So when the ClinGen recommendation was published, they did say that they anticipate that there will be an adjustment of some of the other criteria in order to accommodate for this downweighting of PM2. So we know that the ACMG guidelines are going through a major rehaul. So they're changing the guidelines to be more into the likelihood ratio kind of modeler scoring system, and we're expecting those guidelines to come out probably the early part of next year. So within the UK, both within the rare disease and the cancer variant interpretation groups, we felt that we would not want to implement that downgrading of PM2 until we've got those new guidelines, because we were particularly worried about two families with exactly the same variant being managed clinically different, just depending when their variant classification took place, even though it's exactly the same evidence. What I would say is, for all you participants, is that you won't be penalised if you use PM2 at supporting or moderate. I think there's hopefully now the facility on GTAC that you can actually specify which variant interpretation guidelines you're using. So that would be really helpful to do that, but just use PM2 as you would do according to your own local guidelines.
Thanks for that, Miranda. I mean, that was one of the questions that came up from our colleagues outside of this meeting was, you know, what happens if I use other guidance as well? And you've quite clearly stated that we will take that into account in our assessment process, and we will feed back to the participants as we do so. Emma, I have a question for you. So can we use PS3 and PP3 together?
So yes, we can, but only in certain scenarios. So if you've got a missense and you've got functional work, but you've also got prediction tools, missense prediction tools, you can use them in that setting, but you can't use them when you've got mRNA studies, because if you've got mRNA for splicing, for instance, then you can't use PP3 as well. You should use PS3 in that sense when you've got mRNA. And this is because the prediction is the same. So basically they're saying that you're using the same piece of evidence twice, but you can use it when you've got a missense with functional and using the missense prediction tool. So in that scenario, yes, but not with mRNA.
Okay, great. Thank you, Emma, very much indeed. We have a question from Bethan, which I think Miranda is going to answer, which is, there hasn't been a mention of the use of BP6 or PP5 in those classifications. Are these applicable? Are these acceptable to apply?
Yeah, thank you. So just to clarify, this is the reputable source criteria that was originally in the ACMG guidelines by Richards et al. And then they've kind of removed it because they've said you should really contact the lab to try and get that evidence available. In the CAMBIG guidelines, we have allowed the use of that so that we could basically, if the variant's on ClinVar, I think you should contact the laboratory and try and get that evidence and use their evidence to fit into the ACMG codes. But what we've really struggled with is some of the evidence, particularly from Enigma's multifactorial model, and how we incorporate that into the ACMG guidelines. So we have allowed you to use PP5 and BP6 for Enigma, or in some cases Insight, although the Insight data is a bit easier to kind of match to the ACMG criteria. But as I showed, hopefully in the new 2021 guidelines, we now have a framework for actually applying that Enigma multifactorial evidence into the different points and then into the strengths. So I think I agree, kind of use it in exceptional circumstances, but yeah, sometimes you need to.
Thank you, Miranda. I'm going to stay with you because we've got a question here for one of your variants, so variant 6, and the use of BP2. So is it only valid to use if in trans proven and FA symptoms absent?
Yes. I should have made it clearer. Yeah, that paper did specify that it was confirmed in trans and the patient had no clinical features of Fanconi's anemia. Yes, thank you.
Okay, thank you for that. And then we've also got one here for frameshift variants that are present at very low frequency, one female observation in a non-cancer cohort in NOMAD, we would have to use PM2 supplementary and PVS1, which is not enough to give a class 5. This is variant 2, Emma, so I'm going to come to you. So these variants are clearly pathogenic, and most of them have also been classified by Enigma. We've been using PS4 based on internal data to bump the variant up to a 5, as there's no other criteria that we could use. Could you please provide us with some advice?
Yeah, so going back to firstly what Miranda was saying about PM2 supporting, we haven't actually ratified that in the UK at the moment, so we probably use, you know, we may not use it in the supporting, but I don't, if you did use it in the supporting, like you say, I totally take your point that, you know, these are class 5 and you know it's a class 5, and there's no issue at all as long as you're using PS4, you know, as long as you've got the data to support the use of PS4 in order to bump it up. So, you know, PS4 you can use when you've got 2 unrelated patients with the phenotype, as long as you're not double counting those patients and you absolutely know that they're unrelated. There is no issue in my mind that you can't use PS4 in that scenario in order to get to that class 5. Yeah. But yeah, this is partly, I'm going to come to Miranda, but this is partly, you know, one of these debates that we've had about the PM2 supporting and how it can sort of affect the classification. And this is a frame shift, and as long as it's not in the last exon, and we'll just, you know, caution's got to be applied there, then yeah, in most part there would be a class 5. Yeah.
Great.
Over
Thanks,
to Miranda.
Emma.
I know
yeah,
you want
does
to
Miranda want to come in?
Yes, I'll have a little conversation.
Sorry, only just to say that yeah, we use PS4 quite a lot, and again on from the UK count. So again, it's in a slightly different place, but we've got all those counts from Public Health England, and there's, you know, you can often see it's in ton of 20 probands, and it's once in NOMAD, and you can use that very simple fitted exact test to get a PS4 strong or very strong, which means that you've got no doubt that that variant is class 5.
Great, thank you, Miranda. And Emma. So Simon, back to you. Have you some more questions?
Yeah, thank you very much indeed, Sandy. So we've got a general question here, which I think we covered at the start, but really a question from a participant saying, will this seminar be recorded? And thank you for an interesting seminar. Yes, the answer to that question is it will be recorded, and as we said before, we will make it available, a link available to all the participants sometime in the next couple of weeks. We anticipate it might take up to 2 weeks because obviously the videos have to go through compliance, but generally, yes, the intention is to make it fully available to all our participants so you can review it at any stage. A question for both Emma and Miranda. So this question is there any database or could we evaluate variant position on which we could use to evaluate variant position in BRCA1 and BRCA2? It's a general question. Is there a database we could use to evaluate variant positions in BRCA1 and BRCA2?
So on the Canva UK website, at the moment it's in the process of being updated. At the moment, it's only got the SMVs rather than any frameshift variants. But yeah, that's kind of a very good resource, pulling in all the data from NOMAD or BIC, LAVD, ClinVar, etc. It shows you the in silico tools, the functional analyses, but you can also, there's also a function that you can record your own classification. So if other people have seen that variant and can either upload notes or just kind of, you can just type in and give it a variant classification. I think we're underusing that facility at the moment, but the aim is to get more and more people using it. So we kind of share the expertise and the knowledge that we've got within the diagnostic lab, so that everyone's not having to repeat the same work. So that I would say that's a good starting point for you.
Yeah, I'd agree with that, Miranda. And also just to emphasize, the use of Alamet's also a great tool where you've got a lot of resources all pulled into one interface. ClinVar, for instance, NOMAD is all in there. That's a good tool to use as well.
I think it's clear though, isn't it? It's why, to use a very used phrase, is why reinvent the wheel? I mean, the opportunity is there for sharing our experience and tools do exist to do that. And I think as a community, it's of value to actually use those facilities and share your expertise and experience with your colleagues.
Yeah.
Great. I have another general question. So if I come to you, Emma, first, and then Miranda. So what type of functional analysis could be considered as strong evidences? So what about IHC, saturation genome editing, and other in vivo or in vitro experiments? What's your thoughts?
Yeah, so again, going back to what Miranda said about the CanVig, they've actually called out some of the ones that have got more strength than others. I think genome editing was in there. Miranda, you might have to help me out with some of the others, but there was the cell transfection one not recommended as strongly. There was some that have been called out, so I would refer you to those guidance actually, because it does list them, what they would consider to be stronger, and actually gives them more like a points system on IHC and things like that. So the genome editing one is definitely more strongly.
And I guess it's not just a methodology either. It's about going back and looking at the publication to understand what actually was done.
That's right. And so thank you for that prompt, because also, you know, it's making sure that those functional assays have enough pathogenic variants included, and that at least this one that's being assessed is at least equivalent or surpasses the other pathogenic variants within that functional assay. And also that there's a number of controls that are put through that are clearly, you know, you can see that the function of the protein is maintained with those controls in place. So there's a number of different variables that you need to consider when you're interpreting a functional assay. It's not just the methodology. It's a number of controls, a number of pathogenic variants that have been put through as well. And there's some really good papers out there that, you know, the Findlay paper, for instance, the Bowman paper, which are really sound science behind them, which, you know, would definitely, you know, you'd have far more credibility if a variant was pathogenic and being called out in one of those as well. And they are also listed within the guidance too.
Yeah, thanks, Emma. Miranda, did you want to come in there? Anything else that we should be thinking about?
Yes, I agree with Emma in terms of functional assays, and then we don't get it so often for the BRCA genes, maybe LOH, but within the CanVig guidelines, particularly, it's very useful for the Lynch genes, is that we can use MSI testing and the IHC and loss of heterozygosity to help count towards PP4. So the phenotype specificity, it's not specific to that variant, but it's pointing to that gene. And so if there's other things like that, then that can help you apply PP4.
Great, thanks, Miranda. Simon, back to you.
Thank you, Sandy. So I've got one for either you or Emma or Miranda. So is there a number or value that has a threshold to determine if something has high or low conservation?
I'm not sure. At the top of my head, I can't remember the threshold value. I can come back to you about that. But I do know that the conservation scores are formed from like looking at FAST-CONS and PhyLOP scores as well. And basically, these are the scores that they look at different orthologs in order to, you know, to produce this score. And I can't remember at the top of my head. Miranda may be able to. We can come back to that, what the threshold is. But it is on. So Alamut, how it demonstrates it is using those scores from those systems.
So are we talking nucleotide conservation?
Yeah.
Yes. Yeah.
I think
I use the visual graph in.
Yeah, I'll be honest, I do. But behind that visual graph is these scores as well, and I can't remember.
Or it isn't conserved. It's not very scientific.
Yeah, I mean, like for participants, obviously, I mean, a lot of these questions are coming off directly to our panel. We haven't seen them before, but what we will do is, if we can't answer them now, we will make sure that we get an answer back to you after the assessment in the report. Another question for both of you. I think this relates to variant 6, so probably you, Miranda, but if it was interesting to note that we can use BP4 and BP7 together, are there any cautions one should use when giving two bits of evidence? In the participant station, I don't usually give them both together. So that's BP4 and BP7 related to variant 6, I think it is.
That was actually one of Emma's.
It was. Thanks for that. No, and I take the point actually. I don't know what you think about that, Miranda, actually, because I don't think, I mean, we've used this in run 4. We've never considered that it was double counting, but it could possibly be.
So
it doesn't say in the guidance not to use them together, I don't believe, but
no, and then if you look at the second CanVig publication about the combining evidence, we have allowed it for that. I think it's used. I think BP4 is strictly a synonymous variant, but actually we quite often, so no,
BP7, BP7.
BP7, sorry, is for a synonymous variant. So if you've got no effect on splicing, you've got no mechanism for disease, and so it's it's just, I think, quite commonly used for those variants.
I think a good example of how things are not always clear cut either, and what to use when. Exactly.
Yeah, exactly.
So Simon, I've got one final question from my side until we go back to you. So both Miranda and Emma, how do you determine easily if the mutation is in an important functional domain? So
I suppose, I suppose literature is a good one, and the Enigma paper, because that basically calls out critical regions. I'd use those as a starting point. Miranda, do you have anything else that you use?
I like the Decipher website.
Oh, okay, yeah.
It's got a good kind of graphical view of the gene and shows the functional domains, where all the ClinVar variants are, and then it's got this amazing new tab that shows you where the areas that are not subject to nonsense-mediated decay now as well, which is really helpful.
Great, that's great advice. Thank you both. And then Simon, back to you.
So one last question from me as well. So, and again, it's a general one, is how do I apply somatic guidelines to germline variants? Just to finish off on a nice one.
Well, that's a challenging one there, Simon.
It is a challenging.
I think I said in the introduction, we sometimes, we wouldn't use them in preference to the germline guidance with using BRCA. So with the somatic ones, we tend to use those in a very much a somatic setting, for instance, like looking at RAS genes or that's around a tumour mutation board, where you'd be looking just at somatic variants. And yeah, I suppose you can use them in terms of therapy for BRCA just by categorising, using those categories that are denoted, the 1 to 4, because this is mostly PARP is licensed, and you could use tier 1 for that, but they're almost in support of the germline, but not in addition, not instead of, I should say. And for BRCA, it was important to raise that they're available, but I wouldn't advocate using them instead of the germline guidance. So yeah, you could just still categorise them within the tier. I don't see any harm in that, and I think they recommend in the AMP that most of the germlines are considered within tier 1. But you still have to understand if that variant is pathogenic in order to put it in tier 1. Yeah. So you still need to do that full interpretation and then categorise it as per the AMP. That's how we do it. Okay.
Do you have anything to add to that at all?
Yeah, no, I just fully agree, and I think even if you're doing somatic testing on an ovarian or a breast cancer sample, and you identify a BRCA1, BRCA2 variant, it's got quite a high likelihood of being present in the germline, and therefore I think it's really important for the other family members, etc., is that that variant is classified using the ACMG, AMP guidelines, CAMVIG, whatever germline guidelines, as well as the somatic ones.
Fantastic. Thank you very much.